This is 39 from section 10.3, and I'm just going off my notes. So I didn't really rewrite this, so hopefully you can read it. I think you can. And 39 says, find the slope of the curve at each indicated point. This is the curve, r equals -1 plus the sine of theta, and we want to find the slope at theta equals 0 and at pi. Now the slope, remember, is just going to be dy dx, and that's going to be dy d theta over dx d theta. That's from our polar coordinate definition of the slope. Dy d theta over dx d theta is dy dx. And the slope's usually just dy dx. So we have to figure out what dy d theta is and dx d theta. So we have to change this and put this in terms of x. So we have our conversion over here. X equals r cosine of theta, y equals r sine of theta. So first of all, find x. So x equals r, and there's my r, times the cosine of theta. See, there's my formula. That's why we get a couple of trig functions there. All right? So r cosine of theta, r cosine of theta. So that's our x. And then we distribute this out. We've got negative the cosine of theta plus the sine of theta cosine of theta. And then I'm going to find the dx d theta. That's going to be part of my dy dx formula. So I take the derivative. So the derivative of the cosine is negative sine. So that's going to be negative, negative, positive. So I'm going to have sine theta. Then I have to use the product rule. First times the derivative of the second plus the second times the derivative of the first. And that just becomes negative sine squared of theta plus the cosine squared of theta. Now this starts to grab my attention because if I factor out a negative sign, I've got sine of theta minus sine squared of theta minus cosine squared of theta. And then if I reverse these and factor out another negative sign, making that positive, I've got this, and this is my two-angle formula. So that's a way of simplifying it. I mean, you could leave it like this and run all your values, but this is a way of simplifying it, so I chose to do that. Now let's do the y. So y equals r sine of theta, so y equals r sine of theta. And then if I distribute that out, I get negative sine theta plus sine squared of theta. And then again, I want to find dy d theta. That's going to be part of my dy dx formula. So dy theta, the derivative of negative sine of theta is just derivative of sine's cosine, so negative cosine of theta. Then I've got the derivative of the sine squared of theta. Now this is interesting because this is really the same thing as squared. So if I put the 2 in front, use the chain rule, okay, use the power rule, so 2 times the sine of theta times the derivative of the sine of theta, I get the cosine of theta. Now when I see this, this is my two-angle formula for the sine of theta, so I'll just write this like this. And these are on your formula sheet, so hopefully they're accessible to you intellectually. So dy dx equals dy d theta, which is this guy, over dx d theta, which was this guy. Okay. Now we want to find the slope at theta is equal to 0. So if I put 0 in here, the cosine of 0 is 1, so I've got -1. The sine of 2 times 0 is 0. Sine of 0, which is 0. Sine of 0 is 0. And the cosine of 0 is 1. So I've got -1 plus 0 over 0 plus 1, which is just -1 over 1, which is -1. Oops, sorry, I'm doing all that, missed all that stuff. Okay. So I'll repeat it. Negative cosine of 0, that's -1. Sine of 0 is 0. Sine of 0 is 0. Cosine of 0, 2 times 0 is 0 is 1. -1 over 1 is -1. Now if I put pi in here, the cosine of pi is -1. Again, the sine of 2 times pi is 0 again. And again, the sine of pi is 0. And the cosine of 2 times pi is going to be +1. So a negative times a negative is a negative, so I got 1, +1 over +1, which is 1. So those are your two slopes. The main idea is you want to remember how to change these from the polar form to the XY form using these conversions. Okay, need to know how to do that. And that's number 39.